Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Module 3, Lesson 2, Properties of Dilations. Okay, so in Module 2, we covered translations, rotations, and reflections. Now we're going to talk about something that's called a dilation. So it's kind of like your pupil in your eye. A dilation means something gets larger or smaller. Okay, so we're doing dilations. So the first example says dilations map lines to lines. So we're going to take a look at what they mean by that. So the first thing they did was they gave us this line L. So here is line L. And it looks like a line segment. If you were to ask me, I would say that is line segment L because it does not have arrows at each end. So I'm going to do that. So now it is line L. And on line L is a point P and a point Q. And offset from line L is the point O. That is not on line L. So that is what we're given. So that is going to be our center. And the 2 points P and Q are going to be on L. So this is going to be the center of, let's say, a circle if we were to draw it. And then we're going to draw rays from the center O through each point P and Q. So the first thing I need to do is get my ruler, and we will do that. Okay, so what I've done here is I've lined up my ruler, and I'm going to draw a line from the point O through P and continue up. And let me make that a little bit longer, like so. Okay, so that is a ray OP. So I will call that ray OP, like so. There is ray OP. I'm now going to put my ruler back here, rotate it around to Q, and I'm now going to draw a ray OQ. That continues on through Q and over there. So this is ray OQ. Okay, so there's the first thing we do after we have a point 0 off of line L. Okay, so now I have my compass, and what we're going to do is we're going to put the point of the compass on O, and I'm going to rotate it around, and I'm going to open it, and I'm going to measure how far O is from P using my compass. Okay, so I want to get this as close as possible to P, and it's right about there. Can't get it much closer with the technology here. Okay, so there's my distance from O to P using my compass. Right there. It's pretty close. Okay. So I'm going to draw a small arc right there. Now think of this as, if I went all the way around, that would be a circle. Okay? And with a radius of OP. So I did that just to show you what we're doing, but I'm only going to do this small arc here, just to show a portion of that circle with a radius of OP. Okay, so now that I've got the compass set, I'm going to move the point of the compass to P. So I'm going to move this point of the compass to P, just like that. And make a mark along the ray OP. Okay, so I'm going to move this up to here, put it right on P, and make another mark. Okay, so now what I've done is this distance is the same as this distance, so the whole distance is 2 times the original. So I've doubled, so that's a dilation. I doubled the length of my segment OP, and now I'm going to call this point right here P prime. Okay, so let me write that over here. So I just found the distance of OP using my compass, and the distance of OP is going to be multiplied by 2, and when I multiply the distance of 2 of these OPs, that is going to equal the length of OP prime. So 2 OPs, OP, and this is the length, same length as OP. From here to here is OP. From P to P prime is the same length as OP. So 2 OPs is OP prime, the whole thing. And that's how we denote that. Okay, so now if I take my ruler to prove this, and put this right at 0, rotate this around, you can see that my first point P is 28 millimeters. Well, 28 and 28 is 56, and that's right about 56 millimeters. Okay, I might be off just a little bit, little less than 28, 27 and a half, and this comes out 55 millimeters. So it is double. Okay, so that proves that that is double just by measuring it. Okay, so now I'm going to repeat that process with OQ. So if I rotate this over and put this on here and swing this out until I'm at the distance Q, and let me change to purple now, and I draw an arc there, that's the distance from O to Q, and then I'm going to move up to here and mark it again, and now this point here is Q prime. OQ is this length, Q to Q prime is the same length as OQ, so the length of OQ, if I multiply it by 2, would equal the length of OQ prime. From O to Q times 2 is the same as O to Q prime. Okay, so now let me just move this stuff out of the way here. Okay, so now I've put my ruler on P prime and Q prime, and now if I draw a line through P and Q prime up here, then I'm going to name that L prime. So I've just created a dilated line. So line L is down here. I dilated it up. I doubled the distance from my center O, and I drew a line L prime, which goes through point P prime Q prime. It is going to be parallel to line L, and it's going to be the same length because it goes on forever in both directions. So what we can say about lines being dilated is a dilation of a line is going to generate another line that will be parallel to the original line, and they're going to be congruent because lines go on forever. And I can do that again. I could actually go out again with that same distance, and I'll do that quickly while the computer's paused or the video's paused, and when I come back you'll see that I'll have another line that'll be out this same distance again on both rays. Okay, so now what I have done is OP, this is the same length as OP, and this is the same length as OP, so I dilated this out, I tripled it, so it's a dilation of 3. And I did the same on the green line. OQ equals QQ prime. So OQ is the same length as this, which is the same as this, so I tripled it. And as you can see, these 3 lines appear to be parallel. Okay. So now with these points, and they are arbitrary points, we could have placed those anywhere. I could have moved O closer. I could have moved it over here. I could have had a different angle measure here, in other words. It doesn't matter. Every time I do a dilation along these rays, my image is going to be parallel to the pre-image before. Okay, no matter how many times I do that. Okay, so now we have example 3. Now, in this case, the only change here is O, our beginning, the start of our ray is on line L. So it says what would happen, what we have to think about is what would happen if the center O were on line L. So if the center O were on line L, and if we pick points P and Q on L as well, then the dilations of point P and Q, P prime and Q prime, would they also be on line L? And that's what we need to figure out here. So we're going to get the calculator, or not the calculator, but the ruler and the compass back, and we'll do that. Okay, so first thing we want to do is put this point right on O, like so, and open it until we get out to a distance of Q. And if I draw an arc right there, okay, and I then move my center point of my compass onto Q and draw another arc, then now what I'm saying is OQ is the same distance as Q to here, and I would call this Q prime. So OQ times 2 is OQ prime. It's double the length. Now I'm going to put my compass back on O. I will rotate it around the other way, open it up the distance of P, change that to green. So there is my arc to P. That's the distance from O to P. So now if I move my compass over to that arc I just formed right here at P, then I make another arc. Then from O to P is the same distance. This distance here will be the same as this distance here, and I will call this point of intersection P prime. So L is equal to L prime. 1 prime. So L prime is right here as well. So if L was right here and then I dilated out a distance to Q prime and P prime and drew a line through O and P prime and Q prime, then that would give me line L prime, and it coincides with our original L. So after we dilate a line, it is still a line. So dilations map lines to lines. Okay, and I will write that. Okay, so dilations map lines onto lines. Okay, so here is exercise 1. It says, given center O, so there's my center right here, and a triangle ABC, dilate the triangle from center O with a scale factor of R equals 3. In other words, however long AC is, we're going to triple it. BC we're going to triple, and line segment AB is going to be 3 times as long as AB. So it's going to be A prime B prime, which is 3 times AB, and so forth. So how are we going to do this? Well, the first thing I want to do is put my ruler at my O, and I'm going to draw a line segment, or a ray, I should say, through C. So let's do that first. So if I draw a segment or a ray up through C like so, and I will mark it with an arrow here. So I'm also going to do the same over here. So I'm going to put the ruler back here, rotate it so that I'm at A. I'll draw this in green, and we're going to go out like so. We start at 0. For some reason it's not. Here, let me try this end. That's better. Okay. Up to O. Okay, so there's what we're going to dilate on. So remember, if I move my compass over to O like so, and rotate this so I'm on the red. Okay, I can't rotate too far, I'll lose my compass. How am I going to do this? Let me open it way up and then roll it out this way. Okay, so if I move this to here, there, that'll work. There is the distance from O to C. Okay, so if I make an arc right there, I need to close that just a little bit more. Okay, I guess that's close enough. There's arc OC. Now if I want to triple this, then I'm going to bring this out to here and draw an arc. That would be the double. I need to do it one more time and put my compass right here and draw an arc, and there will be triple. So this point right here is going to be C prime, and OC prime is 3 times as long as C. Now I'm going to bring my compass over, and I'm going to put it back on 0, or O I mean, right here, and I'm going to find out what distance A is, measure A, the distance from O to A with my compass right there, And let me turn to purple this time. So that's the distance from O to A. Well, if I triple it, then I'm going to put my compass on A. There's double, and do it one more time, and put a mark there. And that right there is A prime, which is OA prime, which is 3 times as long as OA. Okay, so now we're going to measure these and prove that. So if I put my ruler on here, since it's already lined up for this one, the length from O to A was 35 millimeters. So this is 35 millimeters. And if I measure all the way out to A prime, I'm at 105. The whole thing, as you see right there, it's 105. So the whole thing, OA prime, distance is 105 millimeters. So 35 and 35 is 70, plus 35 is 105. Okay, so now if I put the ruler back here, rotate it up onto the red line, and we measure, C is 4, so this is 4 millimeters. And if I measure all the way up to C prime, you see that it is, let's see, is that correct? 4.2 actually, 42 millimeters. 42 millimeters times 2 times 3 is 126 millimeters, and that is right at 126 millimeters. So O, C prime, is 126 millimeters, which is 3 times 42. Okay, so now what I'm going to do is I'm going to do the same thing for OB. So I'm going to rotate this through B right there, and let me move this out of the way. Extend this out, and I'll do this one in blue. So this is the segment that we're going to follow all the way down to there. Okay, so now I'm going to do the same thing with my third point. So I put my compass back at okay, so right about there. About as close as I can get with this, and I make an arc. So that's OB. Bring this out to here, make an arc. That's OB times 2, and then I do it one more time, and this will be 3 times the length of OB, and I will call this point B prime. Okay, so what is the purpose of doing all this? Well, we are creating a triangle that is going to be 3 times as large as the original. So now when I put my ruler down, and okay, so if I move my ruler to 0 like so, and then rotate it till I'm at A, there we go, and I will draw a line segment from C prime to A. So here, all the way down to here. So there's A prime, C prime. So A prime, AC is this length. This should be 3 times as long. Okay, so now I'm going to do the same with drawing a line segment from C prime to B prime. It does not like it when there's ink already there. It won't let me track. So there it is there. And then now that I move this down to here at 0 and rotate, and I'm going to end up with this triangle here. Okay, so now if I take a compass and a ruler, we're going to take a look at a few different things. Okay, so if I get my compass, and I put this right on A like so, rotate it so I'm at the 0 degree mark, and then move this to B, okay, that will tell me how many degrees AB is. So I'm at 35 degrees. So AB is 35 degrees. So this our angle right here is 35 degrees. Now if I bring my compass over here and put it right on A, and if you look right there, it should be 35 degrees as well. Okay, 35 degrees. Might be off a little bit just by the angle of these, but this should also be 35 degrees. Okay, measuring this beforehand, I got 38 degrees. So that means this angle up here is also, let me do two arcs by the way, they're not congruent. And this is 38 degrees. And then finally, 38 and 35 is 8 and 5 is 13, 73. I need 107 degrees for B. So this our angle right here is 107 degrees. So therefore this angle right here is also 107 degrees. So what I'm proving here by doing this is the angle measures are preserved under dilations. But the length of side AC is definitely not preserved. It is now longer. Okay. So now A says, note that the triangle ABC is made up of segments AB, BC, and CA. Were the dilated images of these segments still segments? And the answer is yes, but they were longer. Okay? But they're still segments. A segment became a segment, it just became a longer segment. Measure the lengths of segments AB and AB prime. What do you notice? So we're going to go back and do that now. So if I measure AB, so put that right at 0. I'm going to use centimeters or millimeters because they're more accurate. Trying to find a place where I don't have any writing so I can move my ruler. Okay, right there. So from C to A, so AC is a length of 34 millimeters. So I'm going to say AC is 34 millimeters. And that's down here. So since I've already measured it, I'll put it down there. I will say CA equals 34 millimeters. Okay, go back. So I'm just doing all these measurements. Now if I rotate this over to here, that looks like 21 millimeters. So CB is 21 millimeters. And they're asking here how long is BC. BC equals 21 millimeters. And yours will probably be different if you do it on paper, of course, because I'm using an electronic version. Okay, and now I need to move my ruler so that 0 is at B, rotate it to A, and that looks like 23 millimeters. So BA is 23 millimeters. So segment AB equals 23 millimeters. Now I'm going to measure A prime, B prime, and answer the question B. So A prime, B prime is right here. So I'm going to measure from here down. So this is off a little bit with my calculation. So that looks like about 65, 6, 7, about 67. Okay, so A prime, B prime equals 67 millimeters. So A prime, B prime is longer. And by how much? Okay, so I'm off just a little bit. If this were 69, 23 times 3 is 69. What do you notice about this? A prime, B prime is equal to 3 times the length of AB. Okay? So it was really close. I'm at 2.9. I'm almost 3 times. Since my calculation wasn't exact with my ruler, I'm off by just a little bit. Okay, so if we do the same thing for CA and BC, then I should get C prime A prime to be 3 times as long as this, and that should equal 3 times CA, and CA was 34, so 3 times 34 is 102 millimeters, and we will check that. And then finally, C prime C prime should equal 3 times BC, which should equal 3 times 21, or 63 millimeters. So now let's go measure those. We should get 102 and 63, or somewhere close to that. So if I put this here and rotate this over, I'm at 104, and we said 102. So I'm close. I'm off by a little bit with my calculation. Okay, but it is supposed to be 3 times. Now if I measure CB, I'm at 60, 61, somewhere around there, and I was approximating 63. So I'm off by 1 or 2 millimeters because of the way I drew it, but it should be 3 times. Now measure angle ABC and A prime, B prime, C prime, and we've already done that. Angle ABC is 107 degrees. So the measure of angle ABC equals 107 degrees, and the measure of angle A prime, B prime, C prime equals 107 degrees. Okay, it says verify the claim you made in part D, measuring and comparing the following sets of angles. 1, angle BCA and angle B prime C prime A prime, and 2, angle CAB and angle C prime A prime B prime. So we've already done that. The measure of angle CAB equals the measure of angle C prime. This is 2. I'm going to do 2 first. Actually, I could just move it down and do 1 first. Move this here. But I will continue with it. So the measure of angle CAB equals the measure of angle C prime, A prime, B prime, and angle B prime, C prime, A prime should equal, and that should be a measure of, should equal the measure of angle C, that's an angle symbol, angle CAB. So angle BCA is 38, and the other's 35. Okay, this should be BCA. And BCA is angle C. BCA is 38 degrees. And that made the other angle 35 degrees. Okay, so the measure of the prime angle and the original angle are the same all the way throughout. What does this mean in terms of dilations with respect to angles and their degrees? Angle measures are preserved under dilations. Okay, so angle measures are preserved under dilations. Okay, that is the end of lesson 2. Review the lesson summary and go do your problem set.